What's up, everybody out there? Bananas are yellow, oranges are blue. I like monkeys, but they don't like you. Okay, so in this video, I'm going to be talking to you about 8.3 dot products. So what a dot product is, you will see it represented as something like u dot v or w dot y. That's how you say that. You say, oh, focus camera, come on. U dot v, w dot y. Yay, I can read. So what this means, dot product. Say we have a vector going like this, and we have another vector going like this. The dot product of these vectors is basically how much of this vector is projected onto that vector. If you're dealing with electricity, you go into mechanics, you're going to need to know a lot about dot products. So I'm going to show you guys how these things work. Here we go. Yay! So let's say I'm given two vectors. U is the vector where I have an x and a y value. V is a vector where I have an x and a y value. In order to find the dot product, you just take the x values, multiply them together, and add the y values multiplied together. So for example, if I wanted to find the dot product of 4 and, I don't know, negative 87. Yes. Then you can have 2 times negative 8, which is negative 16. 4 times 7 is, I believe, 28. I may get something wrong. I'm trying to go really fast this video because I want to get out of school, and everybody's in Wednesday night school, and they're in my room right now, and it's not even Wednesday, so it doesn't make sense to you, but it makes sense to me because it's Wednesday night school right now, and I'm sad. So negative 16 plus 28 is 12. Yay! That would be our dot product. Dot product is 12. Yay! Looking at another example now. This one, again, I'm just finding the dot product, except I'm given my vectors in standard form. Big deal. 2 times negative 4, those are the x values, negative 8. My negative 3 times 7 is negative 21. If I add those values together, I have negative 29. Hey-o, there's my dot product. Here's another definition for you guys. Two vectors are considered orthogonal. Orthogonal. All this means to you is perpendicular. Perpendicular. If the dot product is 0. So what orthogonal means is perpendicular. The reason, camera, what happening? Why? Oh, hopefully we're back up and running now. I don't know, that was weird, strange. Okay, what was I saying? The reason this word exists, orthogonal, is because if you have the vector 0, 0, which has no direction, it's not going anywhere, it just is the origin, it is considered to be orthogonal with every vector, but since it has no directional value, or length or magnitude, it cannot be perpendicular to any vectors. We're not really going to talk about that, so if that didn't make sense to you at all, it's okay. But yeah, you may see it sometime if you become an engineer or something. I don't know. But that's why that word exists. Yay! So here's some examples. So pretty. So if it's asking you if it's orthogonal, stop texting me. You want to know if u dot v is equal to 0. So in testing that, I can multiply my x's. Now 2 times negative 6 is negative 12, and 6 times 2 is 12. Well, I believe that makes 0, so yes. Shh. Yes. Shh. Yes. Yes. Oh, it's so pretty. Oh. And this one you have 8 times 2 is 16. 1 times 16 is 16. So then this would be 30, ha! Why did I write 13? What's wrong with you? 32, which is not 0, so no. Let's do more math. I told you guys you could buy pink bananas on Amazon. Look at that, 100 seeds, pink banana, whatever that is, for only $9. There we go. That's the right math. Booyah! Okay, going to talk about another concept. Talking about the angle between two vectors. So say I have a vector going that way, and I have a vector going that way, and I want to find out the angle between them. Hey-o, the angle between them. Well, if I call this vector u, and I call this vector v, then the angle between them is cosine theta, the angle, equals the dot product of these vectors divided by the magnitude of these vectors multiplied. This is something you will have to know. Cosine of the angle is the dot product of the magnitude of those two vectors. Now let's use it. Okay, so if I know that the angle between the vectors, that is going to be my theta, and I know the formula cosine theta equals the dot product of these two vectors over the magnitude. The dot product would be pretty easy to find. So I need to find the magnitudes. so let's go ahead and do the dot product. I can't determine what pen I want to use. Hear all that clicking? That's me figuring out what pen I want to use. So the dot product would be 7 times 4, which is 28, and minus 40, so minus 40 over, the magnitudes multiplied, well, x squared 49 plus 100, so square root of 149 is that magnitude. 16 and 16 is 32 is that magnitude, so I have square root 149 times square root 32. So now when you enter this in your calculator, go ahead and simplify as much as you possibly can, such that you would have cosine of theta equals 28 minus 40 is negative 12 divided by, if you are multiplying square roots, don't forget you can just multiply the inside, so this is 149 times 30 to 32. And then when you enter it in your calculator, make sure you do cosine inverse of that. So it looks like yabba dabba do, and then you press enter, and then you see your angle is 100.01 degrees. And then just make sure you are in degrees so that you are happy, and your angle is 100.01 degrees, so that the angle between these two vectors is 100.01 degrees. Okay, same thing. Make sure you memorize this formula. We will use it again, and you will love it because it is very simple. Dot product over the magnitude of those vectors.
Yay, thank you. I love you. Oh, you my boo bear.
I'm sorry I'm so weird. You guys, you know. Alright, another thing we're going to talk about is if vectors are parallel or not. They are parallel if they have a common factor. So what I mean by that is if you can multiply one vector by some number such that it becomes the other vector. So in this instance, I see that 4 is twice 2 and 8 is twice 4. So if I multiplied that vector by 2, a single number that is the same from x to x and y to y, I would multiply those both by 2, then yes, those would be parallel. So, for example, in this instance, I have 2 and negative 12, so if I multiplied by negative 6, that would give me my result, and 6 and negative 36, so if I multiply by negative 6, that would give me the same result. So since I can multiply by the same number, they have the common factor, so yes, they are parallel. In the next example, you have 1/4, well that's 1/2 is double of 1/4, and this is just 1, so 1 is double of 1/2, so I multiplied by 2, and again, yes. If one of these were negative though, say that was negative 1/2, that would not work, because you would have to multiply by negative 2, but this is being multiplied by positive, so it's positive 2, so just be very careful.
Yes, monkey, there has to be a monkey. If there's not a monkey, there's something wrong.
Thanks, Marty!
Alright, this problem you have to think just a little bit about, so take your time, think about it. Yay. So I know that the dot product is supposed to equal 40. I know that vector v is 2, 8, so I know that 2 times some x value plus 8 times some y value is supposed to be 40, and I'm looking for a vector u. So I'm looking for some x and some y value that work. Well, there's lots of different options here. So say that I choose, I don't know, 5 for y. If that's 5, 5 times 40, or 5 times 8 is 40, so then I would have to have 0 there. Well, if I choose 4 for that, that would give me 32, so I would need 8 more, so that would also be 4. Say I choose, I don't know, negative 2, that would give me negative 16, so I would have to add 56 to that, so this would be 28, right? Or you could do it the other way. I'm choosing to do the y's first because that is with the larger number, and it just makes it a little bit easier. Lots of different ways you can do this. Just find something you think will work, and have a happy day. Alright, we're already at our last two problems. So with this one, the vertices of a triangle are these coordinates. Find the interior angles of the triangle. There are two different ways of doing this, so I'm going to do this one two different ways. I'm going to show you guys the way that I like to do it first, but I know that I'm kind of different, and you know I'm kind of different, so if you want to do it the other way that I show you, that's also a very mathematically sound way of doing it. So first thing I'm always going to do is go ahead and draw my triangle such that I have something like this. Okay, so I didn't draw the axes. If you want to draw the axes, you can, completely fine. But it kind of messes with me so I kind of just like to draw a floating triangle there. Because what I'm going to do is I'm going to use what we just learned, the angle between two vectors, and I'm going to make a vector from 0, 3 to 3, 3, such that I would have the vector, what is that, 3, 0? And from 0, 3 to 2, 0, such that they have the same initial point, and they are going away from that angle inside. And this would be the vector what? 2, -3? Because then I can use my formula cosine theta equals the dot product of those vectors. So 3 times 2 is 6, plus -3 times 0 is 0, all over the magnitude. So the magnitude of this, 3 squared is 9, plus 0 square root of 9 is 3, times the magnitude, go ahead, magnitude is that, 4 plus 9 is square root 13 for my magnitude. Don't forget magnitude is just the length of it. If you need some refreshing, go back and watch the 8.2 video. It is the square root magnitude of a vector, I told you to watch the video, so watch the video anyways, but the square root of x squared plus y squared. So that's how I'm getting those numbers. Don't forget that. So then I have 3 times the square root of 13. And then I can use my handy dandy calculator. And get that that angle is 56.31 degrees. Oh yeah! Kool-Aid Man's gonna bust in the room now. He's gonna say, "Oh yeah!" And then he's gonna give everybody Kool-Aid. It's gonna be wonderful. Too bad you're not here for it. You're in Winston at school. I hope none of you actually are. You guys shouldn't do those things. Okay, so now that I have this angle, well, if I knew how long this side was, then I could use law of sines to find another angle. Well, hey-oh, if I make that a vector as well from this point to there, notice how I drew my little vector sign so that the vector is going that direction, then I can say that the vector here is 1, 3. So that should have a magnitude of root 10, square root 10. Yay! And now I can say, that was my first step, and I'm going to do my second step, that I have sine of 56.31 over square root 10 banana phone. And say I want to find another angle. Say I call it alpha. Cross multiply, make sure you take sine inverse. So 3 sine 56.31. Yes, very good. Oh, yes. And then take square root 10. Oh, yes, look at all that math. Oh, it's beautiful. And then, like I said, don't forget to take sine inverse of your answer. Oh, no. No, answer calculator. That's what I meant.
What are you talking about?
So 52.13. So that angle is 52.13. I know that there are 180 degrees in the triangle, so I will say 180 minus those two angles. So 56.31 minus 52.13. Yay. So my other angle should be 71.36. I have 56.31. And I have 52.13. And I'm going to write them all in the same place such that Mr. Pike can find my answers easily, and he is less stressed out when he grades my test, so I get more points in the test overall. I'm just kidding, that won't really get you that much more points. But please write it in one place, and then circle it, box it, do whatever you need to do. It makes my life a lot easier. I love you guys. I try to make your life as easy as possible making these videos, so please. Oh. Okay, here we go. I'm going to show you guys the other way of doing this one now. So I'm going to go ahead and draw my triangle. So 0, 3, say it'll be somewhere over here. So 0, 3, 2, 4 over 2, up 4, 2, 4, and 3, 0. All right, triangle, triangle, triangle. Yay, triangle. All right, I'm going to define these as A, B, and C just to make my life a little bit easier. So now I can find the lengths of all of these by either using the distance formula or Pythagorean theorem if I were to make this kind of a right triangle so that I can find the distance of just that segment right there, because I knew it went up 2 units. Oh, sorry, no, it went up 1 unit and went over 2 units, which would make this distance here the square root of 5. Same thing here, it went over 1 but down 4, so this would be square root 17 units long. And my last length, it went down 3 over 3, so that would be 9, and 9 makes square root 18. So that would tell me that B is going to be my largest angle since it is across from the largest sides. And I know what the law of cosines is, so I can use that to find angle B. So I can say that the square root of 18 squared equals the square root of 5 squared plus root 17 squared minus 2 root 5 root 17 cosine b. Yay, law of cosines. So then it may be easier to simplify this before I plug it in my calculator. So I'll say 18, 5 plus 17 is 22, minus 2 root 5 times 17, so 2 square root, what is that, 85? Cosine b. So I'll enter in my calculator. 18 minus 22 divided by negative 2. Put that in parentheses. Negative 2 square root 85. Yay. And take the cosine inverse of my answer to get that the angle 77.47 degrees. So B is 77.47 degrees. Now that I know one angle across from a side, I can find any other side that I want. That was my first step. Now my second step, say that I want to find, I don't know, angle C. Then I can say sine of B, which is 77.47 divided by, what's across from it, root 18, equals sine of C across from root 5, cross multiply, make sure you take sine inverse again. So square root 5 times sine of 77.47 divided by square root 18. I really hope I didn't mess up in this video. I'm sorry if I did. I promise I didn't mean to. I love you guys. You my everything. 30.96 degrees. Okay, and then just do 180 minus to get the other angle. 30.96 minus 77.47. And I have 71.57. So I have 71.57, 77.47, and 30.96 degrees. Hopefully this video was helpful for you guys. I love you. This is Pike Daddy, peacing out, and looking forward to only making 8 more videos.
Oh yeah!
Bye-bye!